So hello everyone and welcome back. In this session we are going to cover a concept of data structure which is known as queue. So queue is basically a linear data structure that is similar to stack. The only difference between queue and stack is in case of stack you had only one place from where you can insert as well as delete the element. That is you had only one end from where you can insert as well as delete elements. So queue is similar to stack, but in case of queue, we have two ends. One end is for insertion of element and the other end is for removal of element. Okay. So let's see that how can we insert and delete elements in queue. But before that, let's just discuss that on what concept the queue works. So queue basically works on the concept of first in first out. The first in first out concept means the element that is entered first would be the element that is deleted first. So queue is represented with the help of array. So queue is basically nothing but it's an array only in which one end is for insertion and other end is for deletion. So these are the restricted arrays. Queue is an restricted array in which you can insert element from one end only and you can delete element from the other. Consider this example that there is a pipe and suppose there is water moving through this pipe. So the water that is entering the first, that is first into this pipe, is the water that is removing first, that has been removed first. So this is the concept of queue, that is first in first out. Now let's see that how can we implement queue. So I will just clear the canvas. The queue can be implemented using array, structure and linked list. In this session we will see that how can we implement queue using array and some of the index pointers. We need these index pointers so that we can point towards a particular index in which we had to enter the element. The queue can be implemented using array and one index pointer as well as two index pointers. Now, what is the reason that we use two index pointers in case of array? That is, when you implement queue using array, you use two index pointers rather than one. We can implement using one index pointer also, but we implement the queue using two index pointers. So let's understand the reason. Suppose that you have an array, okay? Let me just draw an array here. This is my array, okay? And this array is going to be having 4 to 5 elements, okay? So let me just make 4 to 5 divisions here. That is 1, 2, 3, 4. Okay, so there would be 6 divisions. So as we know that in case of array, we have index beginning from 0. So 0, then 1, then the second would be 2, then 3, then 4 and 5. Okay, so these are basically the indexes of array. Suppose that you are implementing queue using one pointer, that is one index pointer. So how is it implemented? So let's have a look. So suppose you have an pointer that is I that is going to save the index of the array in which you want to insert as well as delete the element. So suppose you are inserting an element. So what you need to do is you need to point this pointer on the 0, that is I is going to be storing the value equal to 0, and then you need to enter the element, that is a of I equal to 1. Here a is the name of the array. Okay, so the value 1 is going to be stored here. Now if you want to insert one more element in the index 1, so what I'm going to do is I'm just going to shift this pointer here. So I is equal to 1 now, and I will just store a of I equal to 2. So 2 is going to be stored here. Okay, similar is the process, that is 1, 2, 3, 4, 5 and 6. So I've inserted 6 elements in this array using the same concept. Now as I have said that you can insert element from one end, and it basically works on the concept of first in first out, that is queue works on the concept on first in first out. So when you have inserted the element here, that is 6 element here, the I is pointing on 5. Okay, that is the current value of I is equal to 5. Suppose that you want to remove the first element, because queue is basically working on the concept of first in first out. So element that is entered first, here element that is entered first is basically 1. So 1 is entered first, so 1 should be the element that should leave first. So you need to move this I to 1 again, okay, that is to the 0th index again. So it is increasing the time complexity. So we are using the two index pointers. That is, we basically use one index pointer for insertion. That is, consider that, let me just clear the canvas. So consider that you have an array. Okay, consider that this is an array that is available with us. Okay, and let me just clear the canvas once again. Let me just draw the array properly this time. Okay, so consider that we have an array. We are having elements stored in the array. Okay, I have divided the array and we are going to have 5 elements this time, that is 0, 1, 2, 3 and 4. So these are basically the indexes. Suppose that I have two index pointers, that is I and j. Consider that j is for insertion and I is for removal. Okay, so when you have this basically two index pointers, one is for insertion and other is for removal, then how can it decrease the time complexity? So let's have a look. So suppose that using this particular j, you have inserted an element on the 0th index. That is, first you need to point j towards 0. So j is going to store the value equal to 0. And then we are going to use the same concept, that is a of j is equal to 1. So this particular element is going to be stored on index 0. Now, when you want to insert one more element, you are just going to move this j pointer. So j is storing the value equal to 1 now. And a of j is equal to 2. So 2 is going to be stored here. Similarly 3, 4 and 5. So now j is pointing on this particular index, that is 4. Now what happens here is that I am going to use a different index pointer, that is I here, to remove the element that is present on the beginning. So what happens is the element is already present, that is before the array, that is both the index pointers were present at -1 before, and as we shift this index to 0, 1, 2, 3, 4 for insertion, I is still present at -1. So when you want to remove the first element, there is an index I available for removal. So you need not move from 4, that is index 4 to index 0 again, and hence the time complexity is decreased. So this particular index I is going to be used by us. So how can we do that? That is, now we are popping out some element and that element is going to be equal to a of I. Okay, and I am just moving this index I to the 0th index, that is index pointer to the 0th index. So what I am doing is I am just cutting this array off, and now there is no empty array present here. So now array begins from this particular point, that is 1, 2, 3 and 4. So basically this decreases the time complexity. Okay, so we are going to implement the queue using 2 pointers only rather than 1. Now in the case of queue, you basically have some of the operations, that is ADT. ADT means abstract data types that are present in queue. The first ADT is enqueue. Enqueue is basically used to insert an element inside the queue, and that particular element is x here. It is the argument of the enqueue function. Dequeue is used to remove the element from the queue. IsFull is going to check if the queue is full or not. IsEmpty is going to check if the queue is empty or not. And peek is basically helping us to get the element without removing it. Now, in case of queue, okay, we are going to use two index pointers, that is front and rear, as I explained you in the whiteboard session. And we need this particular data types that is present in the case of structure. So we are going to implement the queue using structure and array, and I will show you the demonstration in the next part. So this is the following data that we need to implement queue. So first of all, we need a space for queue, that is space variable for queue. Then we need the front pointer, that is for deletion, back pointer or say rear pointer for insertion. So let's have a look at how would our structure be when we implement. So let's move to the whiteboard again and let me just clear the canvas. Okay, so we are going to write a structure, okay, and that structure would be named as queue. And inside this structure there would be 4 elements present, and I will be just putting a semicolon here. So the 4 element would be size. The size would be storing the size of queue. Then int rear, it would be storing the rear index of queue, and it is for basically insertion. Okay, other than it, I am just going to store one more element, that is declare one more element, and it would be front, and it would be basically for deletion. And I am going to declare one more element, that is int star q, and it would be for creating dynamic array, that is dynamic size array, so that we don't store more elements than required. And we are going to implement it using concept of heap. Okay, so this is what queue is all about, and we will see the implementation of queue, that how can we create the queue and how can we create the ADTs of queue, okay, in the next video. So I hope that you enjoyed the session. If you have any doubts regarding the creation of queue, that why we use one pointer and two pointer, and you want to understand it again, just mention yourself in the comment section and we will talk. So I hope that you like this video. Like, share and subscribe. Have a good day.